Hi, I'm Leo from Colab Cambodia, and here is the third video in a short series about basic electronics. In the first one, we discovered the different kinds of components. In the second, we've talked about how to draw a circuit diagram. And in this one, we're going to convert from a circuit diagram into a real circuit using one of these. This is called a breadboard. They come in lots of different sizes. This is one of the smallest ones available. The point of a breadboard is to make it really easy to connect together electrical components without having to worry about wires. If I wasn't using one of these, then in order to connect up a battery and a switch and a resistor and an LED, I would have to somehow attach wire to the ends of all of these different components, string them in a line to make it work. That's quite delicate, it's quite difficult to do, it's not very reliable, it takes up lots of space and it looks messy. So instead, we're going to use a breadboard like this. This breadboard is the same as having many wires in a small space, and it's arranged like this. Here's the outline of the board. And you can see that the breadboard has got two sections, one on each side. So I'm going to draw a gap down the middle to show you that they're not connected to each other. This gap down the middle has got no wires going across it, so no current can flow from left to right unless there's a component across the gap. You can see it's got lots of holes. It's got 5 by 17. 5 by 17 holes. It's 5 across, 17 down on the left-hand side, 5 across, 17 down on the right-hand side. Again, you can get bigger breadboards than this, but for our purposes, we're just going to use a small one. And these are connected in a special way. They're connected horizontally in rows. All 5 holes in a row are connected as if they were a single piece of metal. That means the voltage at any one of these holes is going to be the same. They're not connected to the row adjacent on the right-hand side, so the voltage at any one of these holes is going to be the same as each other, but different from these. This kind of device makes it really easy to hook up simple components into a small circuit. So let's do that right now. We're going to follow the circuit diagram that we made in the last video, and we're going to start with a battery. Positive is red, negative is black. So I'm going to put in a black wire on the top row on the left-hand side and a red wire on the top row on the right-hand side. That's our battery connected up. The next thing I'm going to worry about is this momentary switch. It needs to be connected to the negative terminal of the battery and to one of the terminals of the resistor. You can see it's got 2 legs, and we're going to put it in vertically, like that. One leg is in contact with this row, the top row, and the other leg is in contact with the 3rd row down. Next, we are going to put in a resistor. Here's the resistor we're going to use. One of the legs of this resistor is in contact with the leg of the switch. The second is going to go across the gap. It's going to go from the left-hand block over to the right-hand block. So let's do that. I'm going to put it in anywhere on the 3rd row, and I'm going to choose a random row on the right-hand side to plug that into. So we've just done this bit, our 220 ohm resistor. Final part of the circuit is our LED. Remember I said we can tell by the length of the legs. So I know that this leg is longer, this must be the positive side. For our breadboard, positive is on the right-hand side. So I'm going to put the long leg next to the red wire and the short leg next to the resistor's leg. And we've completed our circuit. But it's not lighting up. The reason is this switch is a momentary switch and it's normally open. In order to light the LED, we just have to press the button. As soon as you release the button, it turns off again. Having this resistor here means that the LED is not going to pull enough current to kill itself. If I was to remove this resistor and just power the circuit with the 9-volt battery directly, it would very quickly overheat and die. Always have a resistor in line with an LED. And that's as simple as it gets. That's how to make a small circuit from a circuit diagram using a breadboard. Thanks.